Hello, and welcome back to Sports Statistics. So, what we're going to look at in this lab is something pretty similar to what we did in the last lab, only we're going to be shifting from football to baseball. So, again, last lab, it was all about how do we make better decisions in the course of a football game. This week, it's going to be how do we make better decisions in the course of a baseball game. And the reason we're using football and baseball is it's a lot easier to do this when sort of the action stops after each play. So if you think about football, you run a play, the whistle blows, the play is over, and you kind of wait until the next play starts. So that sort of gives you that opportunity to say, all right, this is our current situation. Let's make a decision based on this situation. Same sort of thing with baseball. All right. Each pitch is kind of its own unit. After the pitch is over, the ball gets thrown back. Everybody kind of pauses. There's like a bit of a delay until the next pitch is thrown. So that gives us, again, this opportunity to sort of evaluate things after each pitch, after each batter, after each inning. That's a lot harder to do than in sports like basketball and soccer, where it's kind of continuous and there's not like defined stopping points. So, anyways, the article that I attached with this week's lab is just talking about a couple of managers and how they make decisions throughout the course of the game. Because again, that's what this is all about, is how to make decisions. So they talked to AJ Hinch, the now disgraced Astros manager. They talked to Terry Francona. They talked to Joe Maddon. So some of the bigger managers in the game, and just give you an insight into kind of how they do things. All right, so I figured that would be interesting. As far as the lab goes, on the very first page, you're going to see what's called an expected run table. All right. And this basically is the equivalent of that calculator that we used in the football lab. So what we can see here is there's a column for outs, there's a column for runners, there's a column for expected runs, and then a column for the probability of scoring at least one run. All right. So the way that this table works is this situation right here would be you have 0 outs and a runner on first. Second and third are empty. All right. So in that situation, a team is going to average 0.88 runs and they have a 43% chance of scoring a run. If we move here, this would be a runner on second with first and third empty. So again, if you have a runner on second, you're going to average more runs than when you have a runner on first. All right, and then it just goes from there. This would be a runner on first and second, but third base is empty. That would be an average of 1.5, and you have a 63% chance of scoring a run. This would be a runner on third, and first and second are empty. So notice in this one, the average number of runs you score is lower than when you have a man on first and second, or a runner on first and second, but the chances of scoring at least one run is pretty high. All right. And then again, just to make sure it's clear, this would be first and third with second empty. This would be second and third with first base empty. And this would be the bases loaded. So if you have the bases loaded with nobody out, you're going to average 2.37 runs, and you're going to score at least one run 88.2% of the time. And then that just sort of repeats here for what if there's one out? What if there's 2 outs? And it can just give you sort of these average expectations based on the situation. And they pretty much follow sort of convention. Like when there's 2 outs, the averages are going to be a lot lower because the other team only needs 1 out to get out of the inning. When there's 1 out, they're going to be lower than 0 outs because at that point you can get a double play. There's all sorts of things that can sort of get you out of the inning and help you out there. All right, so this is the chart that we're going to be using to answer a lot of the different questions in the lab. All right, and the lab is going to walk you through different scenarios the same way that the football lab walked you through different scenarios. All right, so the very first question says, Derek Jeter was known to drop down a sacrifice bunt in the first inning to move a runner from first to second. We are going to use the expected runs table to analyze this decision. So question 1 says, what is the expected value for a team with no outs and a runner on first? What's the probability that this team will score at least 1 run? So you would go up here, you'd find that situation, no outs, runner on first. You'd read the values off of this, and then you'd write them down for that question. So again, it's just sort of a tool to use that. And then there's going to be a series of questions that kind of walk you through a situation. And then eventually you're going to be setting up these inequalities. All right. So this is saying probability times expected runs from question 3 plus 1 minus p times expected runs from question 2 has to be greater than expected runs from number 1. So when you see one of these, you're going to be setting up a little inequality and you're going to be solving for p. All right. And that probability is basically going to be how successful you need to be for it to be a good decision. Like, how successful does your sacrifice bunt have to be for it to be a good decision? How successful do you have to be at stealing bases for it to be a good decision? So you're going to be setting up a couple of these. It's pretty much the same equation every time, and you're solving for P, and that just gives you an idea of when something's a good decision versus when something's a bad decision. But it's the same idea here of this expected value is equal to a probability times the payoff. So we're calculating different probabilities here to see how good you have to be at something for it to be a good decision. So the example in the stolen base one is like, if you're getting thrown out 9 out of 10 times, you should probably stop stealing. All right. But if you're getting thrown out 4 out of 10 times, should you keep going, or is that at the point where you're really better off not trying to run? So that's the sort of thing that you're gonna figure out and try to work through as you answer the different questions in the lab. I should also note that this expected run table is based on an average team. All right, so we're using this just a single table to keep things simple. But if you were an actual team, you would have your own customized table based on the qualities of your team and probably even the qualities of an individual hitter. Because bases loaded with Mike Trout at the plate is very different than bases loaded with, a pitcher at the plate. So just keep in mind that when you're doing it, this is just sort of a generic table that applies to a generic major leaguer, like an average major leaguer. But if you were an actual team, if you were an actual manager, you would be kind of looking at tables that were more customized to your team, and not just your team, but the individual batters and players on your team. And it might even break down to like the matchups that hitter is facing. So, what are their numbers versus a righty versus a lefty, and what does that do to these expected values and things like that, because they can help make sort of optimal decisions throughout the course of a game. All right, so again, it's going to be very similar to the last lab, just sort of looking at it in a different setting and using a slightly different tool to carry out your analysis. So I hope this was helpful. Best of luck. And of course, if you have any questions, just make sure you reach out. All right, have a good one.